Alright. Not super sure how this is going to work, or if anyone's going to see it, but I figured I would do some more with Super Smash Brothers, try to figure out what's going on with the roll glitch. Make sure it's still. Oh god. Something's unhappy. And so yeah, once again we can see the accumulation of some sort of Z translation. Alright, what's changed since last time is I got my decompiler kind of up to a point where it can actually be useful. So to start out, minimize this. Should learn some hotkeys. Let's just take this function. Oh, great. Okay. To add some more instructions. Turns out which the instructions are used by different games is not entirely consistent. Super Smash Brothers seems to use a lot of likely branches, whereas Mario 64 barely has any. Oh wow, I didn't even put them in there. I totally did. Oh, whoops, because I put that in the totally wrong place. Was there register operations? They are there. You're not. Alright. There we go. Okay. So we can compare this automatically generated version to what I wrote. I guess we could do it side by side. We're starting the return address. We're setting the x, we're guessing is the x acceleration to, well, this thing still looks a little complicated because we don't know what a lot of players are here. Copy this in here. It's a little touch up. So you can see we pretty quickly got to exactly where we were after a bit more work before. So this should hopefully save us a little bit of time. And just for fun, let's do this with the other functions we were looking at. Oh shoot. Right, there's one change I had to make. I haven't handled loops yet. It's supposed to tell me when it finds a loop. Great, debugging on camera, already going terribly. Why? It's just not even getting run, is it? Alright, well, in any case, there's a loop in this function, so we can't necessarily take this for granted, which is kind of a shame. Not sure why it's not. I don't know, that's the wrong function. I'm sorry. What am I talking about? Okay. Totally fine. That exchange going on. Probably just have this automatically append. I'm a little worried about that first line. There must be a... Yeah, shoot, I must have a typo in something. This is saying the convert line is F0 to F0. It should be F0 and F4. Alright, more debugging, great. MIPS documentation. Okay. Should be FS and FD. So what's happening? Where is convert S is in FF format. So that should end up being yeah, I'm clearly doing something wrong with this. Alright. So convert S is where? It's a float op, so it should be handled by this one. And then when we're actually processing it, convert S, assign register, FS, FD. Why don't I print it? Ah, okay, so that is being printed wrong, but it should still be working correctly. Should fix that anyway. If I just do this, it's gonna break everything. Alright, I won't worry about it for now. That means this should be more or less correct. Alright, so this function that we had before, which seemed to be no, but something's wrong. Damn it. Oh, right, yeah, let's get rid of F naught as a... Sorry, this code has been changing a lot recently, so I've lost track of how exactly I'm doing a few things, which is always a bad thing. Alright, one more time. Okay. So this function I had annotated before that it was adding the acceleration to the velocity, which we can see here, at least in the z coordinate at the very end. Oh, I guess I should. All right, I'm doing this way out of order. So this, I kind of rewrote the summary of what we know about the data, the structure of information in Super Smash Brothers here. So I've kind of delineated into functions that we understand, globals that we understand, and then data structures. And so we seem to have found a character data structure that had some velocity information. What I had marked before as previous, I think is probably something like representing a physics object. So something in the game that has physics that needs to keep track of acceleration and velocity, I'm guessing is, I don't know, it's a guess. We'll figure out more. And so I've just kind of annotated, so these are the members of these structs that we have some knowledge of right now. And so the decompiler that I wrote takes some of that into account. You can see clearly there's other information there that we're not familiar with yet, but so let me rewrite some of this. I'm not exactly in a state to release it yet because it looks kind of terrible, as you can probably tell. focus on the structure first. Okay, if that comparison, redo another comparison, so these don't actually matter, they're just chain of comparisons. So if not 50, or 50 and not that, or 50 and 68 and that. So if not 50, or not 68, or 80. Parentheses just to emphasize. Do another comparison. Oh wow, these are all just nested comparisons. Yeah, I have a ways to go as far as making this actually functional, usable. Wow, it's a long line. So what do we actually do in this function? We can kind of verify this here. There's assignments every once in a while to an actual character match. Some important things here happen unconditionally, and then we have a bunch of comparisons and checks. The big one seems to be here. Well, okay, there's this important thing at the very end. We're potentially making a change here. Or here. Yeah, wow, this is actually not much easier to follow than assembly, is it? Still a work in progress, though. Okay, so let's look for our the first change we actually care about here. Here's an assignment to the velocity, so we're checking that. So if DC and 100, we do something interesting. Shoot, is this a loop too? I apologize. This is a more complicated function than I was anticipating. Okay, so we're getting somewhere in the function. If this comparison, so that's what's going on. This is a very strange function. There's a bunch of comparisons. Wow, yeah, this is really, really nested. Well, now I don't know if I trust my program well enough to blindly follow it. Alright. This line at DC, so we add D. Oh no, wait. I forget if I multiplied that by 4. Yeah, I did. Okay. D plus D is -3, so A, 8AC? Yeah, so you can see there's a bunch of jumps to 888 right here. So the confusing thing about this function, this branch here, this important one where, maybe it's not even important, I don't know. there's a lot of different conditions that this one can actually be checking, which is why this is a terrible looking function. Alright, we gotta figure this out though. Alright, at the very end, at least, we're sure. This always happens. There's some addition here. But yeah, there's like we can skip. Yeah, actually, this function isn't handled correctly by my program. Damn. Alright, that's a shame. So I'll just do this by hand, because this doesn't actually look that bad, although we're kind of understanding it better. Which is a shame. It should happen less as just a very low-level kind of function with a bunch of comparisons. So just to reference, we're passing in a not, which is the character. 84 of the character is this physics struct. That's exactly what I wanted to avoid doing on camera, but it's alright. Alright, so T6 is 44 in the physics struct, which is the facing direction. FC we don't know, but we're storing in 50. Alright, okay, we're copying that. So this line should still be right. Velocity, yeah. We're storing F12, which is just a single instead of float. Physics plus 74. We've loaded some other stuff, and we're not entirely sure. Particular F2, it does get overridden, alright. And now we're comparing F14, 0 to F12. And then doing a bunch of other computations, which end up putting, yeah, that looks right. So if that happens with for all the branching is right. So yeah, let's just check that. So we're loading the facing direction into T6, moving that into F4, converting that to a floating point number in F0, multiplying that by F6, which is FC. We don't know what it is yet. And then we're multiplying that by the acceleration. Which is 60, yep, acceleration at x. It's an F10, adding F10 to whatever 70 is, yeah, and then storing it. Okay, so that's all right. And now we're checking that we're actually doing that branch. Oh, wait, one more. Store F10, which is F8 times F2, so we should have this one too, yeah. So we're setting all of the velocities to something that's not necessarily related to what they were before. Though it seems possible that these reference some other velocity, but damn, we're going to need to pull that up again at some point. So let's make this a little bit more interesting, play around with that for a second. So let's see, Mario's character structure is here. So the physics offset 8.4, which changes to C4. Okay. Yeah. Great. So if we're running around, so right now Mario should be running left. We see there at offset 1, 2, 3, 4. 4, we have -1 for that facing at offset 44. The velocity starting next is, yeah, there's a negative number. So then we can ask, can we figure out anything about 70 and 74? They're 0 right now. So maybe not. So, I don't know, nothing obvious there. We could try setting it to something, I guess. But this function that runs every frame seems to set it. Let's set a breakpoint here just for fun. Oh, right, because the game's not going. Okay. Just in case we want to. And is this Mario? Address is 289F40. Yeah, okay. So we're running this on Mario. Alright, so we first make an assignment to what I'm calling the physics object belonging to the character and its velocity. We're making some assignments, and then so here's our first branch, 8858. So this is happening. One way to get here is branch 1 false. So what are we actually comparing here? F14, which we set to 0. In fact, that stays 0 this whole time. Capital set, so it shows up. That never gets assigned to again. So F14 is 0 throughout this whole function. Okay. So if F14 is less than F12, if 0 is less than this new value we just stored at offset 50, which is the z velocity. If 0 is less than that, we'll continue here. So I wrote this totally wrong place. Otherwise, we'll end up here. Okay, it's less than that. The thing is, we don't do anything here. We just compare. Oh, no, we do. Okay, we negate F6. We jump to 89C. Okay, so here we're getting here if the z velocity is positive. So that means moving into the screen, I think. So the position is A4. Yeah, so that's positive z. No, wait. Yeah, that's positive z coordinate. So towards us. If the z velocity is towards us, jump to 5c. So what is F2 otherwise? Okay, they're the same, alright. What's the actual difference here? So how do we get here? This is what this is supposed to indicate, but well, I guess it still kind of is. Alright, well, let's use this. Just some kind of confusing things going on. One thing we can do, alright, maybe this is the better answer. Just make all of the register assignments verbose. Actually display it instead of anything else? Yeah. So here we're going to want F and then okay. Do this one more time. So now we're going to have every single register assignment. Alright. Yeah, I'm still looking at some level at the roll glitch, though I'm realizing maybe trying all this out for the first time in a setting where I'm expecting people to listen to me isn't great. I'm trying to kind of get my workflow functional so I can more efficiently kind of pick apart these functions. I just happen to start with a function that has a lot of nested conditionals and stuff, but it seems important for determining acceleration. Hopefully I'll get past this in a little bit. Alright, so important conditionals. Literally nothing happens in this one. Alright, so I'll just get rid of this. So if yeah, alright, so we did this implication before. If not that comparison, or not this one, or this one, we get another comparison. Right. Oh, right, yeah. Plus 74 was something, which I forgot to really annotate, but alright. Wow, alright, maybe I just need to take a break from this function, because this is... Alright, the ending seems like the easiest part. Maybe let's start there. Let's check, fix that, I guess. It's the easiest part to understand. Okay. We do some comparison, and this is the tricky part because it can be a bunch of different comparisons, maybe, we don't know. Alright, I should merge this down so it actually makes sense, and I need to write this code too. Okay. So 50 and 68, not 80. Not 68. Do they all have 50? Not 59. What do they all have? Something's missing here. Wow, no, these are actually all very different. Which is such a thorny... Let's start writing comments here. Okay. So this first one is just 0 is less than... So something's positive. We don't know what exactly. Physics plus 74. So, alright. Makes it a little bit more interesting. Let's jump in, go to the physics object, and check what's actually changing 74 from this. Oh, alright, so it's non-zero. Now it's alternating between being cleared and being set to a value. Seems to do that pretty consistently. Alright. The value is -3. So it's alternating between 0 and -3 every frame during at least the idle animation. Oh, okay. 0 consistently during the jump. We're here. Running 0. Is it just idle or it's... Oh, it's just shielding. Or just, those are the last frames of the roll. Huh. Now it's not changing at all. That's very odd. Maybe it was only while we were returning. Great. Okay, so definitely while we're returning to the z equals 0 baseline, that thing is non-zero. So let's give this a name. I don't know what to name it for now. Okay, so 50 represents something about sliding towards, we're off of the z equals 0 plane, we're sliding back towards it. I guess a more direct check for that would be setting our z coordinate to something different. 2, 9, 4. Set this to something negative, like, I don't know, C1. Actually take? No. Okay, that worked. Now let's check the physics stuff. Should we bookmark these? Okay, yeah, so now it's positive. So this is definitely something about sliding. The 74 in the physics struct has something to do with which way we're sliding and how fast we're sliding back to z equals 0. So if it's positive, then we compare character plus 74. Sorry, let's add this annotation here. We don't know exactly what it is yet, but it's some float. Call it z slide for now. It seems to be which direction we're sliding. So it'd be if 0 is less than where the physics.z slide. Now we're checking this other thing, which, alright, so let's investigate that. So this is 74 offset in the character struct. 29F40 for Mario. Mark you as well. Oh great, now it's a tree. And now it's gone. Okay. So 74 in this struct. 7 is going to be a B, so B4 here. Oh, that's okay, that's another struct entirely. Great. It's a struct that starts here. That's kind of odd. All right. Checking 24 in this struct. This is 0, 10, 24. So how is this number changing? Is that the right one? No. Where is it? This is 74 in the Mario struct. FC8. 29 FC8 is here. 10, 24. Yeah, it was that one. Okay, great. Okay, so let's see if we can figure out this one. It's changing an awful. Alright, what does it look like during normal gameplay? Seems to also represent some sort of sliding. Because again, it seems to only be non-zero when rolling is happening. It's getting smaller over time, mostly. So what is this variable? Does it look anything like our position? Oh, yes, it is exactly our position. So our position's like in another struct. This is really strange. We're accessing, yeah. Alright, so I'm going to need to rewrite that. Because Mario... Yeah, there's some, so yeah, what's confusing me here is there's this struct that's contiguous in memory here with what I was thinking was kind of this overall Mario information. There's this starting address is Mario's character information, it seems to be anyway. Offset 74 is a pointer to a little bit later, like here, and then here rather, and within this is Mario's position. So this is actually just the Z position, which for whatever reason we're accessing in this particular way. So we can add that in here. Alright, so at 74 in the character struct, there's some other struct, which just for now we're going to call position data, and it's going to have type position, and then we can add a new struct here. And tell it that at, let's see, so 24 was a Z, 20 was, so we started at 1C, is that right? I think so. Okay, so it should look a bit different now. Nope, because I have a typo. Alright. Probably have this set to append also. Oh well. Okay. So again, oh, I didn't put Z side in. Whoops. My bad. Okay. Alright. Now this is starting to look a little bit better. So to start off, we're setting the z velocity to some other thing, which looks like how much it's sliding. I'm glad you think it looks great. I hope to live up to those expectations. I'll probably make a summary if I actually figure something out that's a little bit better production quality. I don't know. Alright, so also maybe when I release the Decompiler, when it's not terrible. Okay. So we're checking. Alright, the important stuff, let's just separate it out so it's a little bit easier to see. We're setting the z velocity there, the x velocity, and setting the y velocity. This always happens at the top of this function. Everything else we really don't know yet, but for now. So there's some facing direction dependent stuff for x and y, which is a little bit odd. Also relies on other information. Again, there's just a lot of data here, not a whole lot of idea in the structure yet. I think we can get rid of most of these register assignments, but just in case we can't. Yeah, are all of the comparisons with... Yeah. Seems like all the comparisons are actually with raw things and happen before the assignment. So maybe this didn't... Oh no, there's a negation there. Okay. It's going to end up being really simple. I'm just not thinking clearly about how it's actually working. Alright. I'm glad to hear that. Probably not showcasing. Yeah, the idea was the software would be able to figure this sort of stuff for me. But this function in particular, like I'm sure the next one will work fine, but this function in particular is just strange because this one where it gets to the line offset oxdc in this function, there's a bunch of ways for it to get there that correspond to different comparisons. So that's I did this before. D plus D minus 3A AC. This conditional branch, the way float computation branches is you first do a comparison, which stores something in a register in the float coprocessor, and then it's checked when you do one of these branches later on. What's weird is that, so if we look at this 88 AC, 88 I8, there's a bunch of jumps here. So there's a bunch of different comparisons that can actually be happening there. Now, a lot of the time it's looked like it doesn't end up mattering, but I don't know, I can't assume that right now. Alright, where were we? Okay. 50 just looks like if 0.0 is less than physics.c slide. Okay. And now okay, now if the z position is less than 0, which would be surprising, then what do we do? We do another potential branch. So how do we get here? So, all right. Sliding cluster. I mean, this sliding thing could be totally wrong. I just find it helps assign names to things to reason through them, reason with them, reason about them. Not really reasoning with them. So now this is 78 represents just a negative z coordinate. And what we're doing here is another branch. So alright, so this doesn't matter. So how do we get here? Some more comparisons happen here. if we're not sliding in the positive direction, I've done this implication so many times, or we are sliding in the positive direction, but we have a positive z coordinate, which seems bad, or we're on the positive side of z equals 0, that sliding thing is also positive, but furthermore, so not okay, so not this, but 0 is greater than the sum of our position and our velocity. So we're going to end up on, so maybe this is actually z acceleration, but that, because, alright, who knows. Okay. So roughly speaking, this is like, can we do this with like short circuit evaluation? I guess that's sort of what we're doing. So really, to rewrite this fully, so not compare 50 is if 0.0 is greater than physics.z slide, or oh, this is going to be annoying. Z is greater than 0, or close data.position.z plus physics.velocity.z is greater than 0. So if any of these are positive, or rather, if this is negative, if this is positive, it's a weird mishmash. If we're sliding in the positive direction, if we're on the positive side, or we're going to end up on the positive side. What do we end up setting here? We set F6. Do we end up using it? Ah, okay. So here's that. So this is where my program may be letting me down, because here's this crazy branch. So this is actually just all the ways to set that. Oh no, or not comp 80. Wow. So there are 3 things here. If any of them, I just want to do this on paper. This is terrible. This is so terrible. So this negation is important to actually look at the assembly for. Damn. So F6. We set F6 up here. Set it again here. So in here we set it to negative F0 before we get to 89C. Oh, okay. So actually that's set no matter what. So if we reach 89C, this is where we're negating it's 24. Which is that z coordinate. So in fact, except for this one usage, so if we enter in this, we load 24, we load the z position. Here we load the z position. So F0 is definitely going to be the z position at this point. F6 is the negative z position. We store it in physics plus 50, which is the z velocity, which seems really weird. So maybe this isn't the velocity at all. I thought we tested that, though. Let's double check. So we're going to open up the, where's the, there it is. Physics. Start running again. I was calling the velocities at 48 right after this. So, control dead. So if I do something silly like we did before, set this much higher, I do go higher. That's what made me think this was the velocity before. This line just doesn't make much sense. Oh, I guess it could just be a weird kind of simple physics thing. Yeah, this is definitely sufficient motivation for me to rewrite the decompiler. I guess I can talk about that too, but maybe that's better for a more produced video. Okay, so the point is, all right, we do a bunch of comparisons and checks, and we're checking if there's three ways to get to this point, right? Because of the three conditions here. There's three branches that lead through this. They have to make it all the way through. So all these have CO, AC, and 94. CO, AC, and 94. So either not 50, which is this one, or CO, AC, 94, or 50, 68, 80. So the interesting one is really this last one. So if you completely skip this block, you can still get here. And in this case, I guess we can look at it down here. In that case, you're getting to, that's right before DC. That's right before this big change. So what's the other way of getting there? Not 80, 68, and 50. So we take the jump at 50. Take the jump at 50. Take the jump at 58. Or no, not 50, 68. Right, we don't take it at 58. We do take it at, damn it, what was it? Not 80, 68, and 50. So we step in at 50. And at 68. Wait, 80 isn't a, what? There's no comparison at 80. Oh, it marks this one, I guess. Oh. Alright. Since we have a debugger on hand, I'm surprised I'm doing so poorly at this. Let's see what actually happens to this function. Alright, so what's it called again? What's its address? Here we go. So right now, I don't think there's any function call, so we can just kind of follow it through. So right now everything's at 0. So let's see what happens to this function in this function when everyone's on the 0 plane. So we do the normal stores. Okay, so there's a jump there. You skip over that section. Skip over that section too. Skip over that section. Skip over that section. Alright, we basically don't do anything except for setting these things, which I'm calling the velocities, but I'm starting to doubt, and jump all the way to the end. So in particular, we don't hit this line. I'm kind of curious about that line. So where is this happening, that negation? Store right before DC, which is BC. -3. What am I talking about? AC. It's right before this. This store. When does this actually happen? This doesn't happen in general. So this is, alright. This is dangerous, making it potentially non... Yeah, I guess what's confusing me is this other branch. So you get here if all these true, or if not 80, 68, and 50. What does that actually mean? So if we skip this entirely, yeah, we still do that. This line takes us right there. 50 takes us right there. This is comparison 80. What happens in that case? What is f6 equal to? So many different screens right now. Alright. So f6, now we should do it where we can track it. So this is the store we're curious about. So we get there. Here it's negated. How else can we get to 9c? Or 98? Well, 98 does it for us. So that will happen. That negation. I think we just get rid of this whole thing then. Because if we didn't, yeah, what does this branch represent? 94, which looks like 64 here. That's this branch. Wow, I'm really sorry. This is extremely challenging to actually navigate. It's not that hard, I don't think. All right, maybe we should look elsewhere for a second. All right, what are we really curious about? We're curious about what happens to Z coordinate during normal roll. We found this was affecting. This seemed to be computing some accelerations. Yeah, I'm gonna table that for now. Let's look at something I can actually make progress on. This function, which seemed to be setting these things, which looked kind of like acceleration, except there's clearly some logic here, some other logic that's happening. And this function makes use of, it computes a bunch of other things. It makes use of a bunch of data, does some computations, which are kind of inscrutable. And potentially does something else here. Well, all right, here. Let's see if this function does anything that we can figure out. This looks a little bit prettier. Wait. No, it's the same function. Oh yeah, that calls that one. Great. Good to know. Okay. So some processing happens setting the accelerations first, and then we enter this function. Alright, we really need to figure this out. It's unacceptable. Comp 50, comp 68, comp 80. So we're running through, we do all these things. What does f0 equal? before any branching happens, f0 is nothing. Okay, we enter here. If we take this branch, hold on, alright, I gotta go through this one more time. The important branches here, the first big one is 50. So if we enter into the stuff at 50, almost all of these do. Alright. If not 50, right, so all the ways of getting here are not 50, 50 and not 68, 50, 68, not 80. All of those enter here, right? No, because it would need to have 94. So that means it just skips out on this. It fails all of those. Scrubbing along this function. $50, we enter. Going along. 68, we don't take the branch. Keep going. But this one we do take the branch to 9C. So this is like an OR, basically. We branch directly to 9C, and we store F6. Well, first we negate F. So F0 gets set somewhere. Where does it get set? Oh, it's... I'm an idiot. It's getting hidden because... I'm ignoring it, right? Is that what's happening? I don't know. Not sure why it's displaying, why it's not displaying rather. Where were we? So, following this through again, we step into this branch, we step into this branch, we skip this and we go right to 9C. We negate F0, so F0 needs to get set somewhere. So yeah, we are loading that. F0 does get set. Why isn't that showing up here? Ugh. That changes. Is that just where it gets set though? F0 gets set to, and everything's said and done, 24. Here it gets set to the velocity. If we enter here, which is what we're saying, right? $50, yeah. Yeah, why is that not showing up? Oh, because it's a likely slot. Ugh. Okay, alright. I'm pretty confident we can just get rid of this now. So this is if if one of these things is true, this negation happens. Or if, yeah, okay. I'm convinced anyway. We pretty much forget all the rest of the stuff. Oh, no, that's not true. Okay, hold on. Not so hasty. So if this last one ends up being true, or we don't enter this at all, so this should just be an else. There's essentially two branches. Either we get in here and we negate right? Where is that? So that's 94, so that's 74. These comparisons are terrible. Can't believe how long this is taking. Wow. Alright. I guess I can talk about why this is so hard. Again, these likely branches are really annoying because this instruction only gets executed if the branch happens, which is really annoying when it sets the comparison, so I can't actually do it beforehand. You want to just say, oh, I can just execute the delay slot before the branch happens, but you can't here because it doesn't happen if the branch doesn't happen. And here it would affect whether the branch happens, so delay slots are terrible. So what happens if you get all the way in here? If you get to CO, which is, which is AO. If you get here, oh, but that's the, something strange is going on here. Right, because they all jump to that AO line. Or they jump to A8. Hmm. Nine C. That jump. That's the one that's messing me up. I'm not seeing why this part matters. Because that negation happens no matter what. Okay, one thing's for sure, if we completely miss all three of these conditions, it gets negated. It also seems to happen if we're in here and we get all the way through this. So, alright, let's actually look at this now. So if the velocity is negative, and wait, that seems like a problem. Oh, because we don't know, okay. Less than that, and position plus the velocity, but we already checked this. Why are we checking it again? Wait, and we set the physics, So the first thing we do is set the velocity to slide. This seems impossible. Is that why this has been so hard to follow? Because it's actually impossible? So yeah, look, what are these comparisons? So, like AC. So we get here. Oh god, no, it's these registers. How are we changing these registers? We're not. We're never assigning them again. Right? I think that's why this is so confusing. It's actually just redundant. I was looking for something that would make sense and that I could figure out and that would mean something, but we just do the exact same checks. So we load F2 from there, we compare it to F14, which is still the same, which is still 0. So yeah, is 0 less than offset 50 in the physics? Is 0 less than the z velocity? But we already know that alright, this is very strange. I seem to just want to change this to ands, because that doesn't actually seem to work. Be disappointed if this is right, because this is so depressing. And then we set the comparison back to character dot velocity z being positive, no matter what. And that's what it was before anyway. Ah, but now we switch it. Okay. Yeah, this is just a particularly thorny function. I don't think the comparison register gets cleared when it's used. That would be different. But yeah, it seems like if we don't enter this at all, it stays 0 less than, it stays that comparison. So we're just, alright, this is actually just recomputing that computation. Is, with the potentially new velocity, is 0.0 less than character.physics.velocity.z. If so, What do we use the temporary register for? Oh, it's a float. Okay. That's less surprising. It's probably 60, yeah. So now if 60 is less than where we'd end up, position plus velocity, then velocity is 60 minus position, so we end up at 60. That seems weird. But that does seem to be what it says. Now this is an odd thing. So we're setting the comparison side to be the opposite. So now if character dot physics velocity, okay. If the velocity is now negative, which is impossible because of the checks that got us here. Not comparison 100. And if not this, or not this. So this wouldn't have been set, so it would still be this. Yeah, this is super weird. So now we're looking at 120, which looks like 100. Ends 00 anyway. No, it doesn't. It ends 90. No, it ends FO. Yeah, here. Okay. So that's this block. How can we get here? What can this actually be referring to? So it could be this comparison right here. How else can we get to FO or EC? F2, it's alright. They're all comparing the exact same thing. So it doesn't actually matter. We'll always be comparing F2, which is newly loaded, to 0. It just might be different. So we actually want this to be an AND. And then this is always, yeah, this will just be the same thing. The velocity is less than 0. So here we're potentially elif no, actually this is an important point. So now we're looking at the stuff around, yeah, 120, which is going to be FO. So what is this comparison? How can we get here? Probably we jump to EC. If we go there directly, we load the velocity we compare is the velocity less than 0. Velocity less than 0, velocity less than 0. Yeah, okay. And this is a branch of false. So if it's less than 0. And the other important thing to note is that this one has a non-conditional jump past it. So if that last thing didn't happen, so elif carry out physics dot less than 0 and this monstrosity we do a similar thing, we end up at negative 60. Okay, so this ended up being very simple, I guess. I should probably check this because I am not at all confident this is what it's doing. But this at least makes some sense. So the first thing we do is we set the velocities to something, which we have to figure out still, but they're something. Assuming they are velocities, who knows? They don't really look like velocities anymore. We potentially set the z velocity to negative the z position. When do we do that? If the sliding thing's, but this seems asymmetrical. Maybe I have this wrong. If the sliding is greater than 0, we're sliding in a positive direction, and we're on the negative side, and we would end up flipping signs. No, we wouldn't end up flipping signs. Shoot, did I forget to flip a sign here? I think I did. Yeah, so the important things here are, well, what that slide thing is, and yeah, this relative value. So, all right, let's test this stuff out. Got the memory open, got a breakpoint on the top of this function. What are we passing in? 289 F40, that looks good. We're looking at, this is the velocity, or will be. So if we set the z velocity, all right, So we're about to analyze Mario here. So let's set his z velocity. Well, let's first set our z position. Have some fun here. So our z position, let's make it something, I don't know, reasonably large. So we can notice the displacement. Okay. Now that we have a position, still at 43, jump to the physics object, maybe. We have no velocity right now, which is interesting. So we're going to step through this. Okay, so here's where those velocities are getting set. Only the z velocity gets set. It gets set to something negative, that same -3 that we kept seeing before. So if we're reading this right, oh shoot, so that it's going to totally skip over that. So it won't negate. Z velocity is 0. So nothing should happen, except for applying that acceleration at the end. You basically skip over a lot of these. Okay, so nothing happened, as predicted. So now what if we set the position so how can we get the velocity to change? So we can make z slide positive and position is negative. Z side is, oh no, z side, oh, damn it, alright, we gotta flip it. So let's flip this to be C2FA. Okay. So now our position is negative. Our slide is unfortunately, well, hold on, we'll see what it gets set to. Change it right there though, so it shouldn't, I was going to do the comparison. Ah, okay, shoot. So I actually have to switch up. All right, let's run around. Okay. Now the slide is positive. Okay. So we're going to jump in. Slide is positive now. Character position is negative, and character position plus velocity should be negative as well because our velocity is 0. Yeah. Well, the velocity is being -3, so +3. So yes, that should all happen. Okay. So if we think this should get negated, or this should get set to negative position. I don't think it happened. Where would it be? It's one of the negation lines. Do we never do a negation? We skip right over it. There. There. Yeah, okay, so it didn't actually happen. So I must have this sign wrong. So I think the idea here is just to cap, there's some default amount that you move per frame, maybe. There's some other stuff, which, yeah, we're going to have to figure this out. And this is saying if it's positive, I don't know why this is asymmetrical though. If the sliding amount is positive and where z-coordinate is negative, and we would end up on the positive side. So if we're going too far, set the velocity to be exactly enough to take us to 0. Which makes sense, but this should be symmetrical, right? I don't know. If 0 is less than, if we have positive velocity and we're going to end up greater than 60, then make us end up at 60. If our velocity is negative and we're going to end up to the left of beyond negative 60, again, send us to where the velocity, give us a velocity and put us at negative 60. So this function, it first does some processing on the velocities and then does some computation, then accelerates. So first we bound our velocity, and we bound our velocity so that the intention would seem to be we don't overshoot the center, and furthermore, we stay within 60 of the center. But then acceleration happens. What's weird is so this z-slide, as far as we've observed, only gets set to 3. So this seems to be, I'm going to keep it being z-slide for now. This seems to be a very important variable. Let's watch some of these things as we do, as we roll. This counts as figuring something out. So despite being really far out, it seems like, again, I should probably turn off the tornado somehow, huh? That'd be a good thing to figure out. I get far enough out so that I'm out. My hitbox is too far away. Alright, let's roll a bunch of times. Okay, so we're pretty far out. I don't know, far enough, anyway. Let's now look for changes in this variable, this z sliding thing. And it's still just negative 3. So that's not changing substantially. Why isn't it getting set to, why isn't the velocity getting set to something larger? So now we can actually just step through this function, d87do. Okay. So the velocity is going to get set in this first bit. We're really far away, the velocity is tiny. So, following through our function, yay. This won't trigger because the slide is negative, so this totally gets ignored. But we aren't going to be crossing sides anyway, so it doesn't really matter. Basically, there can be one oscillation. This should trigger though, right? Oh, actually, I don't know what is our z velocity? Oh, right, it's still this. Our velocity is negative, so this won't trigger. Our velocity is negative, and our position plus that velocity is negative 60. So this should get written to. This doesn't happen. Then we get down to comparison around here. We load negative 60. We add it, we can do a comparison. Oh, but we jump. What? F16 is 600, and 12 is negative 60. Oh, no, this doesn't do what I thought it is. This says don't go past negative 60 on the other side. So this doesn't do anything to, this function is totally irrelevant during the roll glitch besides adding the acceleration. This is just trying to make sure that any oscillations from it don't get out of hand, but it seems unlikely that that would happen in the first place. We need to be, well, I guess we don't know what the mechanism is for deciding this Z slide. But this doesn't seem like the problem. If the damping, if the force that was bringing Mario to 0 were stronger, then this would be important, but this isn't, this function is barely doing anything to compete with the whatever's actually driving the roll glitch. I guess we're not seeing what the velocity, the Z acceleration here is still important.